Welcome back, everyone. Today we will be covering Chapter 14 Calculus, one of the most important topics of the IGCSE AdMath syllabus. In this part, we will be covering integration. If you want to know about the topic of differentiation, it's linked in the description below. So let's get straightforward. So, integration. So, you need to understand that integration is the reverse of differentiation. Basically, whatever you did for differentiation, you are going to reverse the process. So in a general terms, if you integrate, so this is the integrate symbol. So it's a long, you just do a long curve and then this. So it's basically derived from the summation symbol. And integrate here means you're going to group things together. And here, for in the general form, we have ax to the power n dx. So this dx is important when you write. So this shows that with respect to the change in x, you're going to integrate the function. So this general form can be written as, so what you do here is you write the a coefficient as it is, x, you add 1 to the power. So where before we subtracted 1 from the power, now you add 1 to the power. And previously in differentiation, we multiplied the n. So like we bring down the n, so it's basically multiplication. But here we will be dividing the n plus 1. So we will be dividing it with the power. And then a plus c constant. So this c is written because you might not know if there is a constant over there or not. Because as you know, when you differentiate a constant, you will get 0. So when you integrate a 0, you will get a constant or 0. So this is another form here. So this is another general form. So basically when you integrate ax to the n plus b, having a constant after the ax to the n. So here what you do is, as it is, you are going to increase the power by 1 and then divided by n plus 1 and then this b. So basically I wrote this b here as an x to the power 0. So x to the power 0. So when you increase the power by 1, you will get x to the power 1, which is basically bx. And then when you divide it by 1 is the same thing as bx. And then you give it the constant. So here's a small challenge for you to do. So when you integrate the whole of ax plus b to the power n dx, then how do you do this? So I'll just give you a heads up here. So I'll just give you the answer straight away because this is like not part of the syllabus, but it's good to know. So this is basically what we are doing is we are doing the reverse chain rule. So we will use the chain rule, but in a reverse format. So here what we do is when you integrate ax plus b to the whole power n dx, first things you do is you just write ax plus b as it is plus b and you increase the power by 1. So this is the normal one. And then you need to divide it by n plus 1. So as it is. So now since it is inside, then you need to differentiate the inside function too when you're dividing. So that says the reverse chain rule. So it states that you need to differentiate the inside and integrate the outside. So wherever the power is, you integrate that power and you need to differentiate the inside function. So if you differentiate the inside function, you'll get an a. And then the plus c as usual. So this is what, so there's a note here. The challenge question is for you to only try and it's not required by the syllabus. So if you do not get it, so it's fine. So you can just move on with the next part. So let's just move on. So now we will be dealing with trigonometric and logarithmic functions, how to perform integration of them. So in a general format, when you integrate sine x, you will get negative cos x. So previously when you differentiated sine x, you got cos x. So when you reverse it, you will get a negative cos x plus c. And then when you integrate cos x, you will get a sin x. So previously when you differentiated cos x, you got negative sin x. Now when you integrate that cos x, you'll get a positive sin x plus c as usual. And this is the integration of secant squared x. As usual, it's basically you're doing the reverse. When you differentiated tan x, you got secant squared x. Now when you integrate secant squared x, you'll get tan x plus c, a constant. And for logarithmic and exponential functions, in general, if it is e to the x, you just write it as it is e to the x plus c. And when you integrate 1 over x, you get ln x plus c. So basically, you're doing the reverse over here. So this one, I'll just show you the how it's reversed. So d over dx of ln x, when we do it, you get 1 over x. So when you integrate that 1 over x, the reverse is basically what's done. So it's converted back to ln x plus a constant. So hope you understood the trigonometric and logarithmic functions. Now let's move on to the next part. So definite integrals. So basically this is just a formula where still now whatever we did was indefinite, which means that there's a function to it. But in definite integrals, it's basically there's a limit between the integrals. So the function, after you write the function, there will be two limits, and you need to solve for the two limits. So what's the value of those between those two limits? So here in general, if the integration to b, a to b, so how do you read this? So you read this as integrate integrate from a to b. So you're integrating the function from a to b. So that's your limit. The range from a to b is your limit. And which is kx to the n dx. So how you do this? Normally, you first you just do the normal integration for the function first. So basically, you give a square brackets and you do the normal integration, which is kx is raised to 1 and then divided by n plus 1 plus c. So here I have not written plus c. So what's the point there? So the point you need to note here is when you're doing this kind of definite integrals, where you need to basically subtract from the maximum minus the minimum. So, but when you subtract a constant from the same constant, they both cancel. So it's no need for writing the c. So that's why I've excluded in this part the c. So I'll just show you with the c also, like how it's getting eliminated. So then you write a to b. So the formula then states that you start from a and go towards the b. So the formula will be the difference between b and a. So you need to just substitute x to be b first because that's your maximum. So considering it's the maximum. So b to the n plus 1 over n plus 1 plus c. And then you minus the a. You substitute the a for x, n plus 1 over a n plus 1 and then plus c. So now you can see that when you remove the brackets, this will be kb to the n plus 1 over n plus 1 minus ka to the n plus 1 over n plus 1 and c, the minus plus c will be 0. So you don't need to write the c as I told you. So hope you understood how it's done. So this is basically the basics of definite integrals. More of this will be used in finding areas of curve. So you just remember where it is used. So it's easier for you to relate to the function or the application of this concept. So basically this is used to find area under curve. Area under curve. So here's a small practice problem. So let me walk through how to do it. So you got 2, 3, 3x squared minus 2x dx. So you, as usual, you put the square brackets and integrate the function. So you get 3 as it is. X is raised to the power is raised by 1. So you get 3 over the n plus 1, which is 3, minus 2x raised power 1, raise the power by 1, you get squared, and then the 2 comes down. So then it becomes 2 and 3. So now, as usual, apply the formula. Sorry. So as usual, when you apply the formula, you'll get 3 times 3 cubed over 3 minus 2 times 3 cubed over 2 minus, then you get 3 times 2 cubed over 3 minus 2 times 2 cubed over 2. So that's your and whatever you write the answer, that's you. That will when you calculate with your calculator, you can get your answer. So I'll just calculate it with my calculator here. If it is a non-calculator, then you need to evaluate by mind itself. So basically, 3 and 3 will get cancelled. So it will be 3 cubed minus 2 and 2 will be cancelled, 3 squared minus 2 cubed minus 2 cubed. Yeah, so minus 2 cubed. So basically, it's 18. So hope you understood that practice problem over there. You make sure you practice a lot on this because this is a new topic from integration, as you might have not seen it somewhere in your 0580 maths. And it's something new. You need to get the whole hang of it when you're practicing a lot of problems. Then you can get the hang of it and how to use the formula, apply it at different situations, etc. So let's just move on. Hope you understood definite integrals. So this is the basics, and we will move on to some other more practice problems later on in this video. So here's a application of the definite integrals. As I told you, it will be used to find the area of a shaded region or the area under a curve. So here they are asking to find the area of the shaded region, as you can see. So let me just walk you through with this question. So the diagram shows the curve y equals 3 minus 2x cubed and the tangent to the curve at the point half 8. So they are asking to find the equation of the tangent in the form of y is equal to mx plus c. So what you do here is to find the equation of the tangent. So the tangent is a straight line. So your y, okay, let me just write it. So y is equal to 3 minus 2x cubed. So then the tangent is passing at the point half 8, right? So basically what you do first is you find the dy over dx so that you can find the gradient of this straight line. So what's dy over dx now here? So 3 times 3 minus 2x squared. Now bring down the 3. So what I did is I bring down the 3, reduce the power by 1, and you need to differentiate the inside function too. So what is that? So that should be negative 2. So now you get negative 6, 3 minus 2x squared. So at x is equal to half, what is the gradient? X is equal to half. The gradient would be negative 6 times 3 minus 2 times half squared. So that would be negative 6. 3 minus 1 is 2 squared. So now you get for negative 6 times 4, which is negative 24. So that's your gradient over there. So now what you do is just find the equation of the tangent by using the straight line formula. Y minus y1 equals to m times x minus x1. So here y minus the y1 would be 8, negative 24, x minus a half. So y minus 8, negative 24x plus 12. So y is equal to, you need to write it in mx plus c form. So negative 24x plus 20. So that's your answer for part 1. So let me just remember it. So negative 24x plus 20. Okay. So that's for part 1. It's not from the definite integrals topic, but we have since we have already learned it in the differentiation topic, it was also used here. So most of the problems involving graphs, that will be a combination of both the calculus, like differentiation and integration combined. So part 2. So part 2 states to find the area of the shaded region. So how do you do this? So basically the area of the shaded region starts from the y-intercept, so the y-axis, until this where this tangent is meeting at half 8. So as we said that when we do the definite integrals, we will find the area under a curve. So the area under this curve should be this whole area. And then you have to only find the area shaded. So the shaded is still only here. So what you do is you find the approach to this is you need to find the whole area under the curve minus the area of this trapezium. So for that you need to know the equation of the tangent. As we found out, it was negative 24x plus 20. And okay, wait. So y is equal to negative 24x plus 20. So now what you do is, if you find it difficult to write everything in one equation like areas unshaded, it's better to go to do each of the areas. So let's say this is area 1 and the whole of it is area 2. Then you can just find it based on that. So I'll just correct that. Area 1 is the whole and area 2 is this trapezium. So first let's find area 1. To find that, you just integrate and then you need to find the y-intercept over here. So basically it's okay, not the y-intercept, sorry. It should be from a 0, 0, 0. So the x is starting from 0 till half. So you need to integrate from 0 to half the equation of 3 minus 2x cubed dx. So basically that is what we will be doing. So here it is. So as we said from before, we use the reverse chain rule here. So first you just write the square brackets, then you do the normal integration for the first 3 minus 2x cubed, or no, 4 over 4 times negative 2, which is going to be negative 8. So either you can use this chain rule or you can just expand it and then do it term by term. So let's just make it easier for you. So if you are not understanding the chain rule, I'll just make it easier for you. And let's do the expansion of this function. So basically what we do is 0, half, and the 3, you just use the binomial theorem over here. So this would be 3 cubed, which is 27. plus 3 choose 1, 3 choose 1, 3 to the squared, and then negative 2 plus negative 2x, sorry, negative 2x plus 3 choose 2, 3 negative 2x squared plus, so then we touch right to the 8x cubed and dx. So this is your function, and when you do that, you will get 27 plus 3 times negative 20, 27 times 2, that would be negative 54x plus 3 choose 2 is also 3. Let me just verify. Yeah, 3 choose 2 is also 3 times 3 times 4. So that would be plus 36x squared plus, actually it should be minus, sorry. So this should be minus. So this should be just minus. Uh, just make this correction over here. So this should be minus 8x cubed and then dx. So after you're done this, we will just do the integration now. That will be 27x minus 27x minus 54x squared over x over 2, sorry, over 2 plus 36x cubed over 3 minus 8x power 4 over 4, and then dx, and you just equate it for, sorry, and then you just equate it and find from half to 0, 0 to half. So you just use the definite integrals formula to find the uh, answer for this. So I'll just leave this to you to try the answer. I have given enough number of hints over here. So from this, I hope you understood how to use definite integrals in area under a curve, how to find the area under a curve. So this is just the first part. Next, what you do is you need to find area 2 and then minus area 1 minus area 2. So you find the area 2 from the equation of this. So what you do here is you find the y-intercept where it is meeting at. So the length of this times, so the area of a trapezium will be half times the length, the parallel sides, side 1 plus side 2 times the height. So the height over here would be half, the side 1 would be 8, and the side 2 would be when x is 20. So basically it's given to be half times 20 plus 8, which is 28 times another half. So this is basically 7 units squared. So area 2, then after you find area 2 to be 7 units squared, you just subtract area 1 minus area 2 to find the answer for the area of the shaded region. So hope you understood this. How to apply your knowledge to different scenarios based on the question. So as this is another question here, so basically it's the same type. You just have okay, so basically we have the diagram shows the curve this with this equation crossing x-axis at 1, x is equal to 1, and the tangent at 0.47. So show that from 1 to 4 of this equation is equal to 9 2 by 5. So basically you just integrate and then show that it's equal to 9 2 by 5. Hence find the exact area of the shaded region of the curve bounded. So there's basically this shaded region is this part. So what you do here is you again split this into two areas. So the area of the hole under the curve, So this is area 1, and this triangle is area 2. And then, as usual, we do area 1 minus area 2 to find the area shaded. So I just leave this to you to try, and I'll send you the answers so soon in the description box. Okay, now let's go to a new topic, kinematics. So kinematics is basically dealing with velocity, displacement, and acceleration. So basically, you just need to know this chart over here, which I've illustrated, to solve any problems based on kinematics, and just one formula to use when you're doing it with integration, when you're combining kinematics with integration. So basically, what this states here is displacement. When you differentiate, you'll get velocity. Velocity, when you differentiate, you get acceleration. And integration is the reverse of differentiation. So then when you integrate acceleration, you will get velocity. And again, when you integrate the velocity, you will get uh, displacement. So basically, you can think of this as double integration. So here, if you want to go directly from acceleration to displacement, you do double times, two times of the integration, and then when you want to go directly, then you do double differentiation. So you differentiate it two times. So this is basically it. So for these the questions in these part, you just remember these, and then there will be questions with you need to sketch the graph or transpose displacement graph to velocity time graphs, etc. So here's just a practice problem. Okay, I think that's the practice problem over here. So they are telling all the distances are in time and seconds. The diagram shows the velocity time graph. Find the velocity at t equals to 70. So basically they were telling to find the particle travels at a distance of 2750 in 120 seconds. So the distance is basically the area under the curve. So you know that a velocity time graph, the area under curve gives you the displacement and the gradient gives you the acceleration. So basically gradient, when you're differentiating, you get it. When you integrate it, you get the distance or displacement. When you magnitude the displacement is basically the distance. So they have told that the total area will be 2750. So this area here is 300. This area would be half times 100 times. So, okay. Sorry, this would be 10 and this would be V. So this is half times V plus 10 times 40. So this is basically 20 times V plus 10. And here it is 120 minus 70 will be 50 and times V. So half times V times 50. So that would be 25V. So this is 25V. So now they are asking you to find the V from this. So you know that you just equate it. So 300 plus 20V plus 200 plus 25V equals to 2750. So that would be 45, 500. So 2750 minus the 500 and divide that by 45. So you get V to be 50 meter per second. So this is 50. Acceleration of the particle from 70 to 120. So basically what they're asking here is to find the gradient of this straight line. So this straight line, you just find the gradient. So the m would be 50 over 50, which is 1. So yeah. So the rise would be 50. The run would be also 50. So it is 1 meter per second squared. -2. So that's your answer for this 1 meter per second squared. So part B, a straight different particles moves in straight line such that its velocity is after leaving a point is given by this equation. So find the exact acceleration. So you know that they have given you the velocity equation. To find the acceleration, you differentiate the equation. So when you differentiate this d over dy over dv over dx or dv over dt over here. So yeah. So dv over dt. So instead of doing that, it's better to expand this whole thing. So 2 plus 5 to the half. So t times t. So basically this should be okay, then you can just do it directly. I think it's no need to do this. So basically when you do dv over dt, yeah, since this is, you use the product rule here. So t is 1 t times, you can think of this as t times the whatever to the negative or the half, sorry, half. So they use the product rule. First you differentiate t, then you get t squared plus 5 plus half times 1, so you just leave that. And then t times you do half t squared plus 5 to the negative half times 2t. So you don't remember to differentiate the inside function too. So then they're asking you when it is t equals to 0. So basically you substitute it to this equation and then you get the acceleration. Substitute t equals to 2 to this equation and you get the acceleration. So acceleration is basically at 2 dv over dt at t equals to 2. So then there's this question. Explain why the particle does not change direction of for t is greater than 0. So basically here you can see when you have any value for t greater than 0, the velocity will be always positive. So you know that velocity is a vector, and when you change the direction, the velocity might turn negative or to an opposite direction. So basically, if it's moving in one direction, the sign would be same. If it's moving in the opposite direction, the sign differs. So sign becomes negative. So that's what they're asking here. When it is t equals to 0, so you can just give the reason as when t is greater than 0, v is also greater than 0. So the velocity will always be greater than 0. Hence no change in direction. No, there is no change in direction. So this is how you reason for some questions. So there are questions some frequently asked to reason your understanding, and you need to know how to reason, how to use the correct terms or intuitions or your conclusions from what you have learned. So now there is a sketching and converting kinematics graph. So this is basically you just draw here. This is they have given that a particle's displacement time equation is given, and then you need to find the values of t for which the p is equal to 0. So that's easy. You just make the velocity. You just differentiate the function, get the velocity function, and set it to 0, and then find the t values. So then they're asking you to find the displacement time graph from 0 to 6. So basically what you do here is you just sketch it roughly. So basically at 0 plus 2 would be 2, and to the 25 times 2 will be 50. So at 50, 0 will be at 50. So this is your first point. And then you just draw the second, third, fourth, etc. And then you draw the function. So this function is about a cubic function. So I'll just draw a rough sketch. So this should be something like this. So this is a positive cubic function, so it should be this shape. So since they told you to draw, you just need to plot the points on the axis also to find the other coordinates. So you need to find the coordinates, plot the points, then simply draw the smooth curve. So then on the axis below again, for the same for the same what is for the same values, you need to find the velocity time graph. So the velocity time graph would be a quadratic function because when you have a cubic and you differentiate a cubic function, you get a quadratic function. So that should be somewhat like this. So this is your quadratic function. So I'm just drawing a rough sketch, but since it's a draw, you need to plot the points and then draw it accurately. Write down an expression for the acceleration. So basically, you're double differentiating. You differentiate this quadratic function, and this should be a linear one. So the graph for the acceleration time would be a linear one. So somewhat like this. Let me okay, like something like this. So you just need to know just need to plot the x-intercept, the y-intercept, and the points you roughly you sketch it to accuracy. So I think that's it for these kinematics, and hope you understood how to convert kinematic graphs from acceleration, velocity, displacement, and the process of integration combined to the kinematics. So, like how the kinematics is related to the integration topic and how you use integration to find these solve these questions. So, if you have any doubts from this, just drop it on the comment below or through our WhatsApp group, and we will make sure we will clarify your doubts as soon as possible. So thank you for joining me here. So I think this would be the last episode of the IGCSE AdMaths revision, and hope to see you soon in a different subject and different series soon. So thank you. Bye bye.